Alright, let's go over this free response question that we couldn't get time for today in class. So at an excavation site, the amount of dirt that has been removed in cubic meters is modeled by the function f defined above, where g is a differentiable function and t is measured in hours. Values of g of t at selected values of t are given in the table. So here we have two separate functions. We've got f, which we have the equation for, and we have g, which we do not have the equation for, but we do have certain values. So for A, it says, according to the model f, what is the average rate of change of the amount of dirt removed over the time interval from 6 to 12? And so we're looking at the function f, and that is the amount of dirt removed. So we are looking at the average rate of change. And notice right here that f has us refer down to g whenever we're looking from 6 to 12. So if we want average rate of change, we are looking at the slope between the points. So our points here, we've got 6, 306, and we've got 12, 474. So we're just doing slope formula with this. We'll have 474 minus 306 over 12 minus 6. And whenever we subtract these here, we are going to get, let's see, 474 minus 306 is going to give us 168 over 6. On my free response question, you can really just leave this alone. It doesn't tell us to put units here specifically, but you do have units in the problem, so you want to include units. If we do 168 over 6, we're going to get 28. I can't remember if this one is calculator active or not. I'm not sure. So I'll have to double check on that. So this, I don't mind if you use your calculator to help you do 474 minus 306 already. You can do it pretty easily without it. But if you don't know how to do it with your calculator, that will help you that much yet. Anyway, so for 28, we are talking about cubic meters per hour is what we're talking about here, because those numbers on the top, they were in cubic meters, and the numbers on the bottom, they were in hours. So we're looking at cubic meters per hour, and that would be our answer for part A. For part B, it says, use the data in the table to approximate f prime of 9, the instantaneous rate of change in the amount of dirt removed in cubic meters per hour at t equals 9. Show the computations that lead to your answer. So 9 is not on our table, but we can estimate the instantaneous rate of change at 9, which it asks us to do, or approximate here, by finding the slope of the 2 points closest to that point. So in this case, we're dealing with the point 8, 376, and 10, 428. And so if we do slope formula with this one, we'll have 428 minus 376 over 10 minus 8. And here for 428 minus 376, we are going to get 52 over 2, and half of 52 is going to be 26. And this also would be cubic meters per hour. So that would be our answer here. Our next question says, is f continuous for 0 less than t less than 12? Justify your answer. And so here we can see at an excavation site, the amount of dirt that has been removed in cubic meters is modeled by the function f defined above, where g, we know g is a differentiable function and is measured in hours. Values of g are shown. So we know g is differentiable. So since g is differentiable, we know g is continuous on 6 less than or equal to x less than or equal to 12. So we know that part of the function is continuous. We also know that this function here is continuous because it's just a polynomial function. But what we have to show is that the limit from the left and the limit from the right equal each other. So let's start on this one with our limit from the right. I don't usually start from the right, but 6 is where we're going to have a problem. And so if we plug in 6 up here, we're supposed to use the bottom function, which means we look at our table here. And so g of 6 is what we're looking at. And the value for g of 6 is 306. Now, for our limit as x approaches 6 from the left of f of x, then we are supposed to find the value of this function. So we're going to have 48 times 6 plus 6 squared, was it over 12, minus 6 to the third over 12. Again, I can't remember if this is calculator active, but let's grab the calculator for this for the sake of time. And if we type this in, we are going to also get 306. So therefore, the limit as x approaches 6 of f of x equals 306. We also have to show that f of 6 equals 306, which is true because if we look up here, at 6 we're supposed to use g, and that value is 306. So finally we can conclude that f of x is continuous for 0 less than or equal to t less than or equal to 12. Alright, for part D, it says find f prime of 2, the instantaneous rate of change in the amount of dirt removed in cubic meters per hour at t equals 2 hours. So we're looking for the derivative here, so we're going to have to use our limit definition of a derivative. We know we're only looking at the point 2, so I think I'm going to use that limit definition. Limit as x approaches 2 of f of x minus f of 2 over x minus 2. And I know that my function is f of x. I'm going to write down here so I don't have to keep going back up. 48t plus t squared minus t to the third over 12. And so if I find f of 2, I've got 48 times 2 plus 2 squared minus 2 to the third over 12. And I'm going to use the calculator on that. I believe we're going to get a fraction value here. So if you do this in the TI-89, it's just going to give you 298 over 3, or you could hit the green button and enter, and you can get 99.3 repeating there. So we are going to have the limit as x approaches 2 of f of x. So 48t plus t squared minus, I'm going to write this this way, 1/12 t to the third right here, minus this value we just found, 99.3 repeating, all over x minus 2. And so there's really not a lot that you can do here to simplify that. So I'm going to show you how you can use the calculator for this as well. So your calculator will do limits for you. So if you see up here it says F2 algebra. If you go to F3 it says calc. So if you go to F3, number 3 is limit. And so the formula that you want to have for this is you're doing, in the calculator, you're doing the limit of whatever your function is, f of x, comma, x, comma, 2 in this case. So you have to be really careful whenever you type this in. This fraction is not that easy to type in. So you're going to type in, put a parentheses because you need parentheses around your numerator here and parentheses around your denominator. The hardest thing about using this TI-89 is making sure you get your parentheses right in every place. So you're going to have 48. You can use a T if you want, or an X. I'm just going to use a T because it's there. Plus T squared minus, and when I do 1/12, I've got to do 1 divided by 12, close my parentheses, T to the third, minus, and I can't really type in 99.3 repeating really well, so I'm going to use the fraction that I had here, 298 over 3. I'm going to close the parentheses for the fraction, but then I've also got to close the parentheses for the numerator. So each parentheses that's open has to be closed. So we're closing that parentheses from the numerator. Then we're going to do divided by t minus 2. And then, so that has typed in my function here. I really should go back here and change this. If I'm going to use t's, I should say here. We typed in the function, f of t. We're going to put a t, and we're going to put, in this case, 2, because that's what we're approaching. So we're going to put comma t, that's the variable that we're using right here. I've done a bad job of this. These should all be t's right here. I've got them all mixed together. And then comma 2, and then you have to close the parentheses for the limit. And so if you hit enter, you'll get 51. So this limit is 51. So we would say that f prime of 2 equals 51. And so that would be our answer for this problem. Try that on your calculator. See if you can get it to work. Be really careful with those parentheses.